Hi guys, this is the first lesson of Unit 7. As you can see, we're still dealing with graphs a little bit, but this is actually the last lesson that we will have to draw graphs for. So that's very, very exciting. So Unit 7 is all about systems of linear equations, okay? So for the past couple of units, we've talked about linear equations being just the graph of a straight line, okay? When we're talking about systems of linear equation, that just means there's going to be two of them on the same graph, okay? So the definition of a system of linear equations is when two lines are drawn, okay, just like right here, they may cross at a certain point. So they may cross at a point X, Y. Okay, so here in this example I gave for you, here's our system of linear equations. We have one line drawn and the other line drawn here. Okay, these guys do cross at the point 3, 2. So right there, okay? Sometimes they won't cross, and we'll get to that later. But for today, we are going to solve each system graphically. And solving it just means that we draw them out and find where they cross. So the answer I want us to find, or our solution, our final answer, is going to be the point at which they cross. Okay, there are 3 ways to solve systems. So this is the first way. Method 1 is just by graphing. The next lesson will be method 2, and the next lesson will be method 3. Okay, and then we're done the unit. We're only doing 3 lessons for this unit. So to solve a system of linear equations by graphing, we're going to follow the following steps. So our first step is to take equation number 1 and make sure it's in explicit form. An explicit form is where y is all by itself on the left. The number in front of x is our slope, and the number here is our y-intercept. Okay, so I'll just write that in if you've forgotten. So m is slope, and b is y-intercept, okay? So where it crosses the y-axis. And with this form of equation, we can very easily draw it. We'll do the same for equation 2. Then we will graph each line. And then once we graph them, we'll just take a look and see where do they cross. And I want your answer in the form of a coordinate, so x, y. Okay, so here's equation number 1, here's equation number 2. So step number 1 says put equation number 1 into explicit form. So I'm just going to do that work right here. So here's my original equation, x plus y equals 8. Now, to get it into explicit form, I need y to be the only thing on the left-hand side. So as you can see, I need to get rid of this x. Now, I'm going to send it over to the other side. When you take one thing and send it over to the other side, the symbol will change, okay? Or the way you can think of it is if I want to get rid of a positive x on this side, I'm going to minus x because then they'll cancel each other out. But if I do it to one side, I have to also do it to the other side. So then I have y being the only thing on the left-hand side now. And then over here, in explicit form, you want the x term to be the first thing after the equal sign. So I have a negative x. And then this positive 8 just kind of gets pushed down. You can't combine these two because they're not similar terms. If that was complicated for you, don't think of it that way. Just think of I picked up the x and I moved it to the other side, but switched its symbol. Okay, it's like it hopped the fence and I switched its symbol. Okay, so there's my explicit form. The slope is the number in front of x, which is negative 1. And we always think of slope as a fraction. So I've said this before, turn it into a fraction by putting it over 1, if it's not already a fraction. And our y-intercept, where we cross the y-axis at, is 8. We're going to do the same thing with the next equation. So this one's a little bit more complicated. I'm just going to recopy it there. And now, just like I said before, in order to start getting our y all by itself on the left-hand side, we need to pick up this 3x and send it over here. So I pick up the 3x, send it over there, and its symbol changes. So the only thing I have left on my left-hand side is a negative 2y equals, now right after the equal sign, I have that 3x that we brought over that I switched the symbol on. And then this positive 14 just kind of gets nudged over. I'm not done yet because y is not completely by itself. So right now it is multiplied to a negative 2. So to get rid of a multiplication of negative 2, we divide off by exactly what we want to get rid of. But once I do it to one term, I have to do it to every term to be fair. So I have y all by itself because those cancel, equaling. Now here you can't reduce 3 over 2. But what you can do is get rid of two negatives. Two negatives cancel each other out. So we just have 3 over 2x, and then a positive 14 divided by a negative 2 is a negative 7. So our slope is the fraction in front of the x, and our y-intercept is the number at the end, negative 7. So we're done step 1 and step 2. Step 3 is to graph each line. Okay, so here is my y-axis. I'm just going to throw some arrows on each end. There's my x-axis. Okay, so for my first line, I start at where y is positive 8. 1, 2, 3, 4, 5, 6, 7, 8. So I'm going to start at the very, very top here. That's positive 8. Now my slope is negative 1 over 1. So a negative on top means we're actually going down, but then a positive on the bottom means we're going to the right. So we go down 1 over 1, down 1 to the right 1, down 1 to the right 1, down. And you can see the pattern starting to emerge. And that's as far as I can go. I'm going to join those. Okay, and there's the graph of equation number 1. Okay, now I'm going to graph the second one. So the second one says I start at negative 7. So 1, 2, 3, 4, 5, 6. Negative 7's right here. And my slope is positive 3 over positive 2. So positive 3 means up 3. Positive 2 means to the right 2. 1, 2, 3, and then 2 over. 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 That's as far as I can go. I connect my dots, and there is line number 2. And then we can see that they clearly cross at that point right there. So that is my solution. They cross at the point. Okay, so for my x value, we're a 1, 2, 3, 4, 5, 6 over, and then 2 up. We are 6 over, and then 2 up. And that is the final answer. We're all done. Okay, let's do a couple more. So I'm going to zoom in on this solving section here. Alrighty. So for my first equation, let me just write it down. 3y minus 5x minus 15 equals 0. So we have a bit of work to do because we want y to be completely by itself, right? Here we go. So I have to send over the negative 5x and I have to send over the negative 15. So I'm going to send two things over at once. And remember, both symbols change when we do that. So the only thing I have left over on the left-hand side is 3y. Now, right after my equal sign is my 5x, which is now positive. And then the negative 15 came over as well. So that is now positive. Y is not quite by itself. So let's divide off that 3 so that y is completely isolated. 5 over 3 can't reduce or anything, so we're going to leave it at that. But 15 divided by 3 is nicely a 5. So that is in explicit form. So my slope is the 5 over 3, and my y-intercept is at 5. Okay, next one. 2y minus x equals negative 4. Same process. Let's isolate y. So I'm going to bring that negative x, this term here, and just slide it over to that side. So I have 2y all by itself. That x came over here, but the symbol changed to positive x. And then that negative 4 just gets nudged over. The negative 4 didn't switch sides, right? It's still on the right side, so its symbol stays the same. Final step is divide everything by 2. That cancels out. Now, here I have x over 2, or really if you want, that's the same. Because there's always an imaginary 1 in front of a variable if there's nothing else there, right? So your fraction is actually 1 over 2x, and then 4 divided by 2 is 2, and it stays negative. So my slope is that 1/2, and my y-intercept is at -2. All right. So now the graphing part, I'm going to zoom out for a little bit. Okay. So here's my y-axis. Here is my x-axis. If I'm doing line number 1 first, I start at the y-intercept of 5. 1, 2, 3, 4, 5. And then my slope is positive on top, positive on the bottom. So that means we go up 5 over 3. Uh-oh. If I go 1, 2, 3, 4, 5, and then over 3, I'm off the grid, right? So this is where we have to think a little bit. My slope is 5, 3, or an identical slope is actually -5 over -3, because this is a positive fraction, right? And technically this is also a positive fraction because 2 negatives makes a positive. So these are the exact same thing. So if I can't go up 5 to the right 3, I can go down 5 to the left 3, and that will give me the same line. So from here, I go down 5, 1, 2, 3, 4, 5, and then to the left 3. Again, down 5 to the left 3, and that's all I can do. Okay, so remember, you can always go 2 ways with slopes. A line is technically 2 directions, right? You can walk one way or the other. So there's line number 1. Line number 2, I'm going to start at -2. That's my y-intercept. And my slope is positive, so we'll start with that. Up 1 over 2, up 1 over 2, up 1 over 2, up 1 over 2, up 1 over 2. Okay, at this point, if I were to connect these dots and just have a line like this, we would have 2 lines that aren't crossing, and that's a problem. Okay, so remember what I did here is I can go one way or the other. I can go up 5 to the right 3, or I can go down 5 to the left 3. It's the exact same thing with this. I went this direction and I didn't end up touching this line, but maybe if I go the other direction, I will. So the slope can be 1/2 or -1 over -2. So if I start here again and go down 1 to the left 2, and 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 then I connect all of my dots, I can see that these 2 lines cross, and that's ultimately what we want. Okay, so remember to always go in either direction if needed. So that is our common point. So our solution is on my x-axis, I'm at -1, 2, 3, 4, 5, 6. -6 is my x value. And then I went down 1, 2, 3, 4, 5. So down 5 or -5 on my y-axis. And that's the answer. Okay, last one. So again, I'll zoom in on that a little bit. So for equation number 1, 5x plus 2y equals -6. Okay, so by now we should know that we have to isolate y. Let's send over that 5x. So 2y is all by itself on the left, and that 5x got sent over and is now negative. I divide off 2, divide off 2, divide off 2. Y is all by itself. -5 over 2 can't reduce, so it stays as that. 6 divided by 2 is -3. So my slope is -5 over 2. And I've taught you before that when you have a negative slope, the negative can go with the top number or the bottom number. Okay, so that's what I was talking about above, meaning the line can go in either direction. So you have either choice to start with either of those. Your y-intercept is at -3. We repeat with the next one. So I'm going to send over that -10x. It becomes positive 10x, and that positive 4 gets sent down a little bit. Divide off -4. So y is completely alone. Okay, 10 over 4, we have to reduce that. We can divide each one by 2, giving us 5 over 2, and the fraction is still negative. And then 4 divided by 4 is 1, right? But a positive divided by a negative is a negative. So our slope just like the other one, is negative 5 over 2 or 5 over negative 2, but my y-intercept is different. It's at negative 1. Okay. So my first line starts at negative 3, 1, 2, 3, down on the y-axis. And like I said before, my slope is either negative 5 over 2 or 5 over negative 2. So if I do the first option where the 5 is negative, that means I will go down 5, but the 2 is positive, so to the right 2. And that's all I can do. I'm going to go the other way to see how my line goes up here. So if I'm going the other direction, I do the total opposite. I go up 5 to the left 2. Up 5 to the left 2. And there's line number 1. Okay, and then number 2, my y-intercept starts at negative 1 this time. And then I have the same slope. My slope is also negative 5 over 2. So option 1, I can go down 5 to the right 2. Or I can go up 5 to the left 2. And that's all I can do. If I join these, there's number 2. Now you should see something about these guys. That's very interesting. They do not cross at any point, and in fact, they look parallel. And we know they are parallel because they have the same slope. And we learned about that in the last couple of lessons of Unit 6. Parallel lines have the exact same slopes. They have the same steepness. Okay, so if we know these are parallel, we know they never touch. So if they never touch, there would be no solution, right? There would be no point that they ever cross at. So in this case, this is a case of no solution. Okay, so if you ever see lines with the same slopes, just stop because you know there's no solution.